Today, we are going to talk about the application of derivative. I will describe what is derivative. Then Han will explain the model. Next part, July will give an example of the model. At the end, Gloria is responsible for commenting. So in general, derivative is describing the rate of change of a vertical variable with respect to a horizontal variable. For instance, the amount of money your employer owes you compared to the length of time you worked for him determines your rate of pay. The comparison is made in the form of a ratio, dividing the change in the first quantity by the change in the second quantity. When both changes occur during an infinitely short period of time, the rate is said to be instantaneous, and then the ratio is called the derivative.
Now I will give one example. Find the maximum and minimum of function y equals to 6x squared plus 48x minus 12 at the interval from minus 5 to 2. From this question, we can know the endpoint is minus 5 and 2. The first step, we need to know the stationary points. When y dash equals to 0, 12x plus 48 equals 0, and then we can get x equals minus 4. The second step, when x equals minus 5, 2, and minus 4, we put those results in the original function. When x equals to minus 5, the y equals to minus 102, when x equals to 1 equals 108, when x equals minus 4, y equals minus 108. From those results, we can know 108 is global maximum and minus 108 is global minimum. So when x equals 2 and y equals 108 is global maximum. When x equals minus 4, y equals minus 108 is global minimum.
In the function graph, there are some special locations known as global maximum and global minimum. On a closed interval, global max presents the largest value of y on the function, and inversely, global min is the smallest y value. Global maximum or minimum normally occur at the stationary points, the endpoints of interval, the points of discontinuity, and the points of non-differentiability. To figure out which points are global max or global min, there are 4 main steps. The first step required is finding the stationary points which occur when the derivative of function equals 0. Next, we put the value of stationary points into the x location and calculate the function's value at these points. Then, we do the same things with endpoints. Finally, depending on the final results, we can make a conclusion. Global maximum occurs at the point giving the largest y, and the point with the smallest value of y is global minimum.
The application of derivative can be used to find the global maxima and minima values of differentiable functions in their domains. By calculating the global maxima and minima, we can know the optimal value of the product. It can be used in physics, chemistry, space station, aircraft, and economics areas. In addition, the derivative could be used in risk management by hedging a position to protect against the risk of adverse move in an asset. Hedging is the act of taking an offsetting position in a related security, which helps to mitigate against price movements. It also can be improve market efficiency for the underlying asset and help reduce market transaction cost. Therefore, the application of derivative is useful in our life.